Hear me?
Oh, hello everyone, and thank you for attending today's webinar, Inventory Modernization with Data Integrity Assurance, the Key to 5G Network Automation, sponsored by Amdocs and Atrinet. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is a Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open on your screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Omdia's Principal Analyst, James Crawshaw.
Thanks, Becky. Hello and welcome everyone to this webinar about inventory modernization and data integrity assurance. My name is James Crawshaw, and as Becky said, I'm an analyst with Omdia. I'm joined today by Marcus Buchner, who's Director of Product Management with Amdocs, and Roy Cylon, who's VP of Technologies with Atrinet. I'm going to start off with a brief introduction to some of the key themes in the telecom and technology area, and then we'll go into more of a deep dive into the topic of inventory with Marcus, looking at inventory modernization for 5G, and then we'll hand over to Roy to talk more about the data integrity assurance aspect. As usual, we'll have around 15 minutes at the end for audience Q&A. So as we go through the presentation, if you think of any questions, please put them into the widget, and we look forward to answering them. So, as you all know, much better than me, telecom networks are going through a lot of change. They're becoming more dynamic, more disaggregated. SDN, NFV, Open RAN, edge computing, cloud native, IoT, and now we've got the metaverse, the artist formerly known as virtual reality. These are all of the major technology trends, and at the heart of it all is 5G. But no sooner have we got comfortable with new technologies like OpenStack and the industry is moving on to Kubernetes. And just when I figured out that K8S was shorthand for Kubernetes, I learned in preparation for this webinar that there's a K3S version of Kubernetes, the Kubernetes Lite. So look out for that in the slides ahead. Now, all of this technological change goes hand in hand with a lot of business disruption that the telecom operators are facing. They're dealing with customers that are empowered through regulation to switch providers really easily. And now with eSIM, you can do that with just the click of a button. You've also got new entrants in the market. At one end, we've got the launch of lots of low Earth satellite systems that are going to eat into the rural connectivity market. You've also got public cloud providers who are bundling voice services, even offering private mobile networks to enterprises. And then the traditional competition, well, that hasn't gone away either. Most markets around the world pretty competitive with multiple mobile operators and at least 2 fixed access wholesale providers, and then of course a lot of asset-light retail competitors. And all of that leads to pressure on margins because in many cases, frankly, what the telco is selling, connectivity, is a fairly undifferentiated commodity. Now on the plus side, there is a burgeoning digital economy out there, but the question is, can telecom operators capitalize on it with new services? So let's assume that the answer to that question is yes. I think that question is perhaps for a different webinar. Let's assume the answer is yes, they can successfully monetize new services. But telcos can't do that unless they can modernize their infrastructure. They can't realize revenue from service innovation or generate a return on all of these investments in network infrastructure unless they can do something as simple as fulfill a customer order and do it efficiently, rapidly, and at scale. And this service fulfillment, it's a key system within an operator's OSS. It enables the timely activation of a service, provisioning according to all of the technical and business rules that have been defined up in the northbound BSS layer, but also in the southbound network resource layer. Now, when service fulfillment systems were originally built, operators had a relatively small number of services that they offered to consumers and enterprises. But today, the number of services increased significantly. That's an attempt to avoid the commoditization that I mentioned earlier. Service complexity has increased too, and services are now provisioned over multiple network and technology domains, and also to lots of different types of user device. The customer is more demanding. They expect this sort of digital experience. They want to order and control their services through a self-service portal or a mobile app. And just like when they request a music or a video stream from one of those providers, they expect a rapid response from their telco, whether it's activating a new service or making a change to an existing one. But there are gaps in the whole digitalization of the processes within a telco that result in a big lag between that first click to place an order and actually receiving the product. That's the result of a disconnect between what we often see as consumers, the slick digital user interface, and then what's happening in the background, those sort of legacy back office processes. Now, service fulfillment processes are pretty complex. This diagram here on the screen is a very simple sketch of an order to activation end-to-end process flow. It does give a sense, though, that there is a lot of complexity involved. All of the interactions between different systems, from the CRM and sales system all the way down to the network elements themselves. Digitalizing the service lifecycle operations from end to end and driving this digital to network automation, this is key to reaping the benefits of all of that network investment that operators have made. In practice, most operators today still have got lots of different siloed fulfillment and inventory systems, one for each type of service or for each network domain. There might be some semi-automated steps, but there's still a lot of manual effort to handle exceptions and errors. Now, as the previous figures showed, inventory systems are at the heart of the communications network operations. Inventory is essential for the fulfillment or orchestration workflows like order to activate. It's essential for assurance or observability workflows like trouble to resolve and root cause analysis. And inventory also helps all of the resource, asset, and workforce management functions that operators perform on a day-to-day basis. The existing inventory solutions that operators have, often they're decades old. There have been a lot of advances in technologies, things like databases, and that means that these systems are a prime candidate for an upgrade that can help to transform the operational effectiveness of the telco. The quotes you see here on the screen are from telecom operators that we interviewed recently about their automation challenges, and data reliability and inventory errors were topics that came up time and time again. They are faced by operators, both fixed and mobile, across the globe. Now, this graphic is from an article you find on a website called Passionate About OSS. It explains the TM Forum's working group on inventory of the future. And the 6 key things that set next generation inventory apart are its speed, its flexibility, data integrity, the machine learning aspect, the scalability, and the security. You can check out the website for more details, and of course the TM Forum working group itself will hopefully have some documentation. What are the benefits of this future inventory system? Well, it's about improved observability, it's about better resource allocation, hence better return on capital. It's about getting faster operational insights, reducing your time to repair. It's also about more automation, hence more efficiency, more productivity out of your staff. It's about greater reliability of the network and the service, and that, of course, leads to a better customer experience. And all of this serves to enable new products and services based on things like 5G, smart cities, open APIs, partner ecosystems, all of the good stuff we talked about at the beginning. But it can also lead to some pretty substantial cost savings for operators, and you'll hear some examples of how telecom operators have achieved these savings from our speakers today. So with that, oh, sorry, those were the last two builds there. With that, I'm going to move to our first audience question poll for the day. Which is the most important reason to undertake inventory modernization in your view? Do you think it's about the simplification and efficiency? Is it more about the ability to manage your next generation infrastructure? Is it about network function and OSS infrastructure outsourcing, moving from on-premise to the cloud? Is that a catalyst, a reason why? Or is it about supporting next generation services, 5G slicing, for example, or private mobile networks? Whilst you have a think about your answer to that question, I'll just remind everybody that the last 15 minutes or so of today's webinar will be for audience Q&A. I can see we've got some questions in already, but please keep firing them in, and we look forward to answering them in a little bit. Okay, I'm going to push out the results now. We've got the most popular response. About 46% of you said it's about supporting next generation services. The next most popular response, about a third of you said it's simplification and efficiency. About a fifth of you say it's managing next generation infrastructure. Nobody called out the third response. Perhaps that was poorly phrased by me or a little bit confusing. But interesting that wasn't picked as the top. Obviously, all of these are reasons, but we were trying to force you to pick one. Marcus, if I can bring you in at this stage, when you talk to your service provider customers, which is the typical catalyst? What's leading them to have a conversation with you about inventory?
Yes, James. Thank you very much for the perfect inroads. The picture what we see is, I would say, is pretty aligned what we see in our marketing interaction. I'm glad to see that people think about really services, because services is where the money is, right? All around infrastructure costs money. Being more efficient is great, so improves the bottom line. But first of all, services is what brings the top line, gets the top line up. So we believe this is a very good opportunity for people responsible for these back office systems, and OSS typically is really back office, right? To claim a business case that it is worth doing something. So not a surprise. It's a good confirmation of what we can see. A bit surprising is there's a delay in moving to the cloud as a reason. We see many people thinking about it, but not everyone is actually acting on it already. But there's an increasing interest. If we do this a bit later, again, I would assume there will be some ticks in there. So with your permission, I'll push on and I'll tell you a bit about what we Amdocs have come across. We provide everyone knows, hopefully, we provide a suite for OSS and network orchestration operations, including inventory underneath. We have got a very good footprint, so plenty of interactions with our market. I'm trying to tell a bit about the challenges, a couple of example use cases, and finally the ingredients to resolve that. This is what we all would love to have. Right? Every one of our customers would have something like that, a thin layer of inventory, just as James introduced. Inventory is a foundation for network deployment, fulfillment, and assurance. Key business functions all residing and relying on the same layer of foundation. This is the theory. This is ideal. In practice, the world is much worse. What we have seen, all of our customers, they have got plenty of these inventories of all ages, new ones, old ones, homegrown ones, acquired ones, and so on. And the reason for that is well known as well. It is technologies, because many of them got built as part of introducing a new technology, like 2G in the past, 3G, 4G, but fixed line technologies as well were reasons to introduce new inventories. New lines of businesses, more the service side, like we had in the poll, or M&A. Many of them many of our customers have this problem of post-acquisitions running almost equivalent inventories in parallel, and then they need to think about how to best bring them together. So what is the impact of that? Clutter of databases always means data duplication. Once you have data duplication, data might be out of sync, might be wrong. It's hard to amend, and it's hard to optimize. So this is what drives actually the urgency, because 5G brings again more technologies, more services to the table. So again, on a landscape which is under tension already, right? There is additional requirements, and there is additional need for clean up quickly in order to manage the challenges of the future. Let me tell you only 3-4 slides of small use cases, what we have come across. So when we talk about 5G, right, this is a network. Left-hand side is the access, the RAN part. Typically, right-hand side is more the core part. So there is, at the bottom, you could say this is the infrastructure bit, more the physical side of the house. Left-hand side is RAN, or if you then look at IoT, there is use cases such as asset management, CPE, or more general IoT asset management. Typical use cases is site management or densification. Still, you would have here in the center, the number 3, you would have the need for building the backhaul network or upgrading the backhaul network. So it's kind of the resilient QoS-enabled transport for both the core and the backhaul and the aggregation networks. Increasingly in the past, given CSPs have an increasing need of building data centers, or the data center part, the IT part of the data center has been growing, of their central offices have moved towards a data center shape. Right? What we increasingly see is managing the infrastructure in the data center. From the physical side, what is shown here, and what is shown on the top is what sits on top of that physical side of the data center, which is the virtualized components, because they need to be orchestrated as well. The more virtualization, the more orchestration of virtualized components is necessary. And finally, and this is what brings the money in the end, this is the end-to-end services. And we see that 5G promises many different new services, a manifold of services. But the bigger the manifold is, the harder it will be to keep an overview on what has been deployed. And this is one of the key roles, the number 6 here, of inventory. As an example, I would say this is still maybe one of the simpler ones, enhanced mobile broadband, a typical service tree. Service tree means all the components, all the elements which are relevant to deliver a service. Is a mix of dedicated ones and shared ones. And the service tree keeps track on how this overall tree is being composed. What is shown here is what we call the decomposition tree. What is not shown is that each and every bit on here has got its own life cycle. Right? It can change over time. So the inventory needs to keep track of the status and the life cycle and the change of each and every element over time. And something else which isn't shown here is the interdependencies. In reality, there's dependencies across this tree. So in reality, it's a mesh, not a tree. So another one, quite something different, we call it a B2B use case, but increasingly for the world, I would say super important, right? It's clever or smart farming. So you could try and use drones, which monitor the fields and try and find out where is the need for distributing water and fertilizers. So it's a clever mechanism to improve and optimize the distribution of fertilizers and waters. This is the business use case, but what is required behind it in the background? So again, it needs hardware like drones, tractors, maybe cameras to monitor, but it needs a whole load of application infrastructure. And this application infrastructure is partially located in shelters at the farmhouses, or it is located to some extent in the data centers as the virtualized part of the apps. So again, service tree needs to keep track on what is out there and monitor the various pieces, because if something's going wrong or something's not working, service inventory will be inquired on the question which pieces are there and which could be the ones which don't work. So a final example. This is more now a bit going into the futures. The previous one was slices in terms of one slice gets configured and many customers hop on a single slice, right? More static kind of slices. The next version is once slices become transient, which means actually customers would want to order a slice for a certain period of time. In here, it's a couple of beverage companies, and they order slices for some purposes over a certain period of time. And so time is one aspect, the second aspect being geography. Every one of them uses or needs to have resources available and get services in a certain area. So time and distribution across geography is the key element where inventory will have to keep track. Forward-looking. It's not only the past. It's not one-time configured. It stays there until it's being decommissioned. No, it's the other way around. Inventory needs to look ahead and try and understand which resources are still available at what point in time and what part has been consumed. So this is only just a few ideas on what we have seen in our discussion. The one with the agricultural optimization is actually already in production, on lab level in production. So it's not really super future. It is something which exists. So we can expect many more of these use cases. So let's think about ingredients. What does it take to bring together both the new requirements and, on the other hand, remember the first picture, to clean up the clutter of all these existing inventories. This is very often the starting point of the journey, right, and is a journey. It is not, inventory modernization is never a big bang, single trick pony thing, which happens overnight. No, inventory modernizations are journeys. So they start very often with siloed environments. Every system has got its own UI, its own workflow. Data are overlapping. Data are partially duplicated, which makes it hard and enforces swivel chair between the systems. So what we see, what people like, what our customers really like when we started discussing and finding solutions, is that we do not just think about the new next shiny inventory. We think about providing an inventory which covers what is uncovered yet or not yet supported, and then we provide this inventory federation layer across old and new, bring old and new together, and this, as you can imagine, provides visibility northbound, both for interactive users, here shown as a monitor, and through APIs for the northbound processes, which is the one shown at the beginning: build, orchestration, operations, fulfillment, and so on. So establishing this inventory federation layer and establishing inventory infrastructure for the stuff which cannot support it today, but is now required, this is the key first step. And then you can start an iterative process of consolidating, retire some of them, consolidate some of the other ones, grow the new ones. So over time, you can clean up the landscape. In the end, the number of inventories, the number of overlaps will reduce. So the question is, what is this inventory federation layer? I touched on some of it, these 4 boxes. We touched on the service inventory. For sure, it needs a common UI. It needs some workflow allowing to build automation flows across these systems. But one of the key elements is what we call the federation data backend strategy. So this is the question, how to deal with the different data which are distributed in different environments. How do we bring them together? A couple of examples are flavors. The first flavor is what we find, right? In grown environments, in grown landscapes, we see that people started in the background running synchronization processes, duplicating data, running synchronization processes point to point between them. That's great, but on the other hand, it doesn't solve the problem of of the swivel chair. Still, people need to do a lot of swivel chair to find all their data. And the more you do this peer-to-peer things, the more the whole thing becomes a mesh, and it's very hard to resolve and to automate and to evolve it. This is why people started doing something else. And this is maybe the most obvious approach, to build a replicated store of the data, replicate the data into a centralized store, and then make it accessible northbound. Then at least you have got all data visible. The problem is, it might not be real time. And the other problem is, how do you write back down very often? But at least you get around a bit the swivel chair problem. So what is the third one then? The third one is being maybe even more clever to say, rather than replicating data, is find the right mechanisms to reference data and map the data, which means if you're looking for, let's say, connections across all your systems in the different domains, you federate queries downwards and you get results back, merge the query results back, and then you move a single queue northbound. So this gives you a single access, and you have got something in real time. Now, you might think the right-hand side is the best one. Not necessarily, because actually what we see in discussions with customers, there is many parameters and many really metrics which decide which of these approaches is best. And easy to guess, typically what is required is really a mix of all these federation approaches and use them all in parallel. Right? Otherwise, it will not work. So let me summarize briefly. We started, remember the query, we started with this one. What are the key drivers? And we found out new services, upper right corner, is the key point here. But the other ones are important as well. And we expect in next-gen cloud nativity and next-gen infrastructure to come up here as well. Simplification from the cost perspective still is something. And one key area of simplification and efficiency is the one we are going to look at soon, next couple of minutes with Rui. This is the synchronization, discovery, and accurate data. But what I would want to close with is, James started saying, yes, we see the need for inventory modernization, and we see this from strategy firms as well, telling us it is one of the super hot topics for this year. So they see a lot of interest in that, and we can only confirm from the Amdocs side, we see the same thing. We have always got multiple projects in parallel. We have really a good track record, so we can only encourage, get in touch with us. We are really passionate about inventory modernization. And with that, thank you very much. James, let me hand back to you for questions. And for next poll.
For the next poll, yeah, fantastic. Thank you, Marcus. That does bring us to our second audience question poll for the day. So how accurate would you estimate your current inventory system is, or your current inventory systems in aggregate? Would you say they're less than 50% accurate, between 50 and 85, 86 to 99%, or 100% accurate? Again, whilst you're thinking about that, just remind you to keep submitting your own questions. Thank you for those that have submitted them so far. We look forward to answering them in the last 15 minutes or so of the webinar. We've got a few responses in so far. Oh, they keep coming in. I tell you what, I'm going to push out the results and then maybe do an update if we get some more come through. This is what we've got so far. So nobody is claiming 100% accuracy. About a third of you are saying it's less than half. About half of you are saying it's somewhere between 50 and 85, and then the remaining fifth say it's at the high end of the range. I'm not sure if you're able to sort of quantify this so precisely, Marcus, but do you have a sense from talking to operators, what is the accuracy to the extent that you can put a number on it? Where would you say reality is based on your customer engagements?
I think it's pretty much the right ballpark. So if I should have guessed, was supposed to have guessed, I would would have assumed this will be the biggest one. And the percentage is one thing, but the big problem is always the impact on to the service fulfillment side, and whether there is impact on resolution of problems from the SLE perspective. Yeah. Right. So even if it's a small percentage, a relatively small percentage, which is inaccurate, nevertheless there might be a big impact.
Okay. And Roy Cylon from Atrinet. Do you have a similar perspective? Are you seeing, are you working with operators and able to get it up to 100%, or is this something you can't really quantify so precisely, Roy?
Yeah, I think the 100% is feasible, but in most situations, before applying DIA solutions, the picture is quite grim. I'm even according to my experience, is even more pessimistic than Marcus. Usually we see it's about 50-50%, actually. I'm quite happy to see that at least the operators have the sense that their inventory systems are indeed non-accurate. Because we've actually had at least a couple where there was a tremendous surprise when they've seen the actual numbers. And again, this of course impacts all of the various network automation flows tremendously. We think is super important to bring the level as high as possible.
Yeah, and that acronym DIA, of course, it's Data Integrity Assurance, is in the title of the webinar. Great. Well, with that, tell us more about DIA, Roy.
Sure. So first of all, thanks very much to Marcus for the nice leeway, and thanks very much, James, my favorite moderator, who've passed these couple of years of COVID at home with a lot of webinars I've seen of you. So always a pleasure. So I'm going today to drill down on data integrity assurance and what it is. We thought the perfect sort of header to this is connecting the dots, and I hope as we go along you'll understand why. So James and Marcus have already spoke a little bit about various challenges that operators are facing in relation to inventory, but I'm going to again look at everything really from the perspective of inventory inaccuracy and what does this mean. So the main challenges really that we see here when your inventory is inaccurate is first of all, you don't really have the accurate info in order to do proper planning. It's not just, the technical operations of planning, but this also tremendously affects your sales team in the various upsell opportunities. For example, if the inventory is not accurate, they don't even have enough information in order, for example, to offer folks VDSL upgrade instead of ADSL. And when we're talking about 5G, if you don't have enough information about the various mid-haul or front-haul capabilities that you have, you cannot really understand where to deploy and if it is feasible to deploy new sites. In addition, really, what we see a lot is fulfillment fallouts, trying to configure a new service, a new slice, some new resource, and reaching failures coming at the end from the elements because you're trying to utilize some resources that are already in use. And this is really one of the major, factors that the operations team spend a lot of time on. Sometimes fixing fulfillment fallout can take quite a few days of work from a team, and you really don't want to spend your time and money on these kind of situations. When we're talking about service, it's not only the initial service fulfillment Imagine that you have an existing service and you want to modify it, you want to add sites, you want to change some configuration, change the SLA that a slice is provided with, delete a service. Again, if you don't have the accurate information in the inventory, all of these life cycle operations of the service will hit various errors. For example, you might delete some chunks of the service, but some strands of it will remain, and they will actually remain there forever if you don't have the proper knowledge and view of what's happening, and this will just be burned out until the end of time. Lastly, we've seen over the years that the various network service fulfillment and the service assurance systems have sort of went each their own direction and become quite distanced from one another. And if there is no joint inventory system that is used by both of these, then eventually what you end up with is that you cannot really do a proper service or slice assurance, because you're trying to assure something that you're not even completely aware of really where it stands in the network, what are its endpoints, its SLA as it was initially configured. So taking all of this, the correct picture, after applying a data integrity assurance and making your inventory precise and accurate, this is the correct picture, where you have accurate data in your inventory, which allows you to do the planning, the upsell opportunities, allow you to do the proper fulfillment, and following that, apply various service lifecycle operations, modification, enhancement, and deletion, and also tying this perfectly into the service assurance systems. So you can really reach the goal of, autonomous closed loop operations, where the service assurance system really assures the service as it's configured and can give the proper insights to some workflow manager, for example, to fix the SLA by applying some automatic configuration back to the network. So this really can only be achieved with an accurate inventory system. Usually, we're talking about inventory as part of an OSS layer, and this is really the focus of the discussion today. But from Atrinet perspective, really, the inventory data integrity assurance is the pillar of every network automation framework, regardless at each layer it resides. So either in the OSS layer, but also if we're talking about lower layers of the network, for example, a domain controller that manages the transport domain, or the wireline domain, or the run domain, all of these various systems that their work is around network automation, from our perspective, should rely on the main pillar of an accurate inventory, which is achieved by a data integrity assurance engine. So if we're talking about a lower layer, so fault management, performance monitoring, configuration management, zero-touch provisioning, all of these also rely heavily on having an accurate inventory with a precise information inside it. So again, this is a very similar picture to what Marcus has shown with different colors. So this is the situation we see a lot of operators actually still operating with really siloed inventory systems that are disconnected from the network itself. The correct picture, really, is the one that we see on the right. So the data integrity assurance basically is an engine that sits between your network and your inventory system and provides full synchronization between the information as read from the network and the information as read from the main inventory system. Now, just talking about immediate low-hanging fruits that can be achieved. So we've had quite a few, for example, scenarios where upon immediate deployment and a few days of getting synchronized with the network, we've found, for example, quite a few pieces of gear, of network elements, sometimes in the CapEx worth of a few $1 million that were not written at all in the inventory, which means basically that no one is using them. They're just sitting around like rocks. Another good example is various off-net third-party connections, third-party pipes that are connected between the operators' systems to third-party providers. And once you start reading the information about this from the network, in a lot of cases, you quickly get to the conclusion that a lot of these pipes are not in use at all. There's no cross-connects or any services actually that are traversing them. So immediately you can detect a lot of actually resources that you're paying for and not actually using at all. So big money wasters. So these are just examples for really low-hanging fruit that can be achieved. Now, if, of course, now we're going to the other end of the spectrum. Let's, for example, look at the 5G world. And this is actually a very oversimplified picture because we're just showing here, of course, all of the network domains and the slices, but actually there are multiple layers that are involved here in each of the slice. And when we're talking about the RAN and Open RAN domains, of course, we also have these transport mini domains interspersed between the RU, DU, and CU elements. And usually we'll have quite a few vendors that are managed in quite a few management methods. And you will have different inventory systems and controllers. And really, this is quite a huge number of what we call data sources to deal with. Okay? And the trick here is not to do a brute force discovery of the network each set intervals. Because if you're going to do that, you're going to overload your network with management data going back and forth. You're going to overload your inventory system with tons of read-write operations. Really, the way to do that is in an optimized way. So, for example, what we're doing is relying a lot of discovery based on triggers that are associated to various network events that we listen to. And only upon specific network events that have been signified as such, the auto-discovery engine will then pop into action and perform a synchronization from a specific domain or subdomain. This is really the only way to make the data integrity assurance work reliably and be able to scale in the complex networks that we have today, which are going to get even more complex going forward. Here we also sort of give a glimpse where what is inside the data integrity assurance. So you see two main legs here, the auto-discovery piece and the reconciliation piece. So I'll deep dive into each one of them. And we also see, for example, the target inventory system. In this case, we've shown the Amdocs network inventory, where both companies have a pre-integrated solution already deployed in quite a few operators around the world. But the data integrity assurance engine can basically be hooked up into any inventory engine by having a specified pipeline that allows it to convert the network information to the target data model, which resides inside the target inventory system. And this is one of its most important features. So let's really look at a common day in the life of a data integrity assurance engine. So we start by defining the discovery domains. which again can mean connecting directly to network elements, PNF, CNFs, VNFs, connecting to some controllers, whether it's vendor controllers or open source or third-party controllers, connecting to various inventory systems that are already in place. Then basically what we start doing is harvesting the information from them. So we start at the basic layer of just getting the topology, the basic inventory. Of course, we're usually talking about multi-layer topology, IP MPLS, optical. We want to gather all of this information. Then we start scraping or harvesting the actual configuration that we find in the various network elements, in the various network functions. This is what we call raw data. All of this is reflected back to us in a very vendor proprietary way, or maybe in the standard way, but usually there will be 10 different standards in your network. You must know what I'm talking about. We have to take this data and normalize it, okay? We do this by converting the data to what we call a unified model. Why is this necessary? Because the step after this would be to convert the data to the target model. The target model is the one that you're using inside your inventory. And what you would want is that the data inside your inventory would really fit the specific models that you're used to working with. This is, for example, a capability that Amdocs inventory provides you. You don't want your inventory vendor to enforce the models on you. You want to be able to define the way, for example, a P2P E-line service looks like. You want to define the way a slice looks like in your inventory. And that's perfectly fine. That's the way it should be. You also want to be able to change and modify these models as you go along. So the discovery and the reconciliation engine have to basically catch up to that. They have to take the network information, a thread from the network, and make all of the correlations and stitch the different layers as we see in this simple example, and deliver to the inventory the network service information in the way that the inventory systems knows how to make use of it and populate its own rows in the database. So this is really the heavy lifting of the auto-discovery. It's not just about being able to connect to the different network elements and read the information. Really, this crunching and transformation work is the super important and heavy one. And if you go a step further, what you want is to be able to modify these flows in the same agility that you are able to change the way the network service models reside in your inventory. So a day in your life might look like, okay, I want to change my slice model to now add some various SLA attributes that were not there before. So you would want to be able to apply this change in the model automatically also to your DIA engine. And this is exactly what we support by having basically everything model-based. And these models are kept and maintained in a codeless manner. So you can basically do these changes in the models yourself. So this was a lot about the auto-discovery piece. Now, what is reconciliation? So what Bruce Lee says here has zero bearing on network reconciliation, but, you know, Bruce Lee, so school. What really is reconciliation is basically shown here. So you must have heard, you know, a lot of people, and even we ourselves at Atrinet are always saying network is the master, network is the master, network-driven inventory. That's all fine and well, but it's really a marketing buzz, because at the end, you don't just read what's there in the network and overwrite your inventory. You cannot do that, because sometimes actually what you have in your inventory system overrides what you have in your network. For example, here we have a service that already has a couple of planned sites residing in the inventory system. These, of course, are not yet installed in the network, so we cannot just overwrite what we find, otherwise we're going to eliminate all of the planning processes. And this is really a simple example. So the reconciliation engine must be it's the one that really finds the discrepancies between the network and the inventory, and must have the capability to automatically make the reconciliation of what to take from the network and what to take from the inventory. And doing that with as less manual input and interruptions from the end users. So using a lot of complex workflows that automatically make the decisions for you. And if we're talking about 5G, then, now the picture really explodes. So instead of just PNFs and simple math services, which are quite complex by themselves, we're now having all of these different entities that we have to gather the information from. So it's a lot of new data sources, a lot of new management methods, and a lot of actually things that are moving around, which first of all make it very challenging to the discovery piece to gather all of the information, and double challenging for the reconciliation engine to find the discrepancies and do the automatic reconciliation on your behalf. And this is something that we've managed to crack, I think, very nicely. I'll finish by coming back actually to the poll question. And this is really the average data of accuracy we usually see in legacy systems. So really 50-60% accurate information, which is almost like flipping a coin each time you want to make some network automation operation in your network. So with this level of accuracy, you can just throw away your inventory and live without it. But really what you should do is take a combined solution like a next-gen inventory system with a DIA engine and reach a level of accuracy which comes to 100%. And this is achievable, even in these quite complex scenarios as we see. And I bring it back to you, James. I believe we are due our Q&A session.
Yep, fantastic, Roy. Thank you very much. And bonus points to anybody who spotted the K3S there in Roy's slide deck. Well, one of them was a bit of an eye chart. K3S, you heard it, or I heard it here first. Okay, that does bring us to the audience Q&A. So thank you very much for those that have submitted their questions so far. Let's start off with this one, Roy and Marcus. How do you go about building relations between network domains, starting with planning and for discovery? Are the products that or the solutions you've talked about today, are they offering tools that help to automate topology discovery? So apologies if that wasn't clear, but it's broadly about the sort of solutions you've been discussing. I guess the answer is yes, they do help to automate topology discovery and work out relations between different network domains, understanding the topology. I guess that's a yes and a yes, but Marcus, do you want to start us off on that?
Yes, you're certainly right. I think this is the intention. Inventory is supposed to keep not just a list of unrelated entities, but the key thing of inventory is to understand all the relations between the objects, and topology is one of them. And I'm sure Roy, you can add something, because I think you even showed it on one of the slides, that this process of, from the raw data, deriving complete topologies, this is one of the key steps in this process. And this is what is of super high value, that because the topologies in the end is what enables many of the services. So topology is key, and yes, tooling is there. And I'm sure, Roy, you want to add a word on that.
Yeah, definitely. Topology discovery is part and parcel. It's one of the basic building blocks of DIA solution. Of course, actually, when you do the network synchronization, you are doing much more than just the topology discovery. And this is done inter and intra domain, of course. You should also be able to do not just the basic topology discovery, but a multi-layer topology discovery, going all the way from the optic layers to the Ethernet IP MPLS layer, and then being able to do, for example, even go to the underlay and overlay, for example, of SD-WAN, slice end-to-end. All of these I consider a sort of a topology, and in this is a pretty basic building block for an accurate inventory. So definitely it's a mandatory, and it's done.
That's great. Thank you, Roy. Thank you, Marcus. Okay, next question here. Somebody asking about inventory of containerized network functions. So I think the point is you've got these very dynamic network functions orchestrated with Kubernetes, but they might be on 1 minute and off the next. So how do you keep track of that inventory?
So let me start with this, Marcus. I'll hand it over to you. So first of all, from, again, discovery perspective, it's about adding additional data sources. Of course, again, this being telecom, it's not as simple as just Kubernetes, because today you already have, I don't know, 5 different orchestrators that are doing also containerized CNF's orchestration. So you have to add a lot of data sources, and then it goes to the reconciliation piece. Usually you would trust the orchestrator about the placement of the CNF, but on the actual configuration that you find on these CNFs, this is now getting more complicated in regards to what to take from the network or the CNF database, and what to take from the inventory database. Marcus,
Gotcha.
You want to add anything?
Yes. Yeah, that's exactly right. And I think it's excellent that, James, you picked this question, and thanks to the person asking it. It tells us quite clearly, right? So we keep talking about inventory, but let's be honest, there is a wide range of different objects to be managed, from super static ones, the very physical ones like racks, right, or distribution frames. Hardware static distribution frames is one side of one end of the range, and the other is Kubernetes, or everything which is dynamically instantiated and then even brought down later. So how can the inventory, be the umbrella across all of it? It's not super easy, but one of the key concepts is that the inventory needs to understand which parts it can rely on. It has, for example, it needs to understand its reconciliation status. Right? We talked about reconciliation. It needs to understand which part have I really can I trust my information on. So information in the inventory needs to have qualifiers on trust. So that's one prerequisite. The other prerequisite is certainly it needs to understand some areas where it doesn't make sense to rely on offline information. It will, if this information is from a northbound system required, it will always reach out to the system underneath, discovering it, or with a real-time connectivity. Right? Inventory at least needs to know the pointers. Where do I have to look for? This is the key information. Even if the nature of the information is so dynamic that it doesn't make sense to store it, at least it needs to store the pointer where to find it. Okay?
Fantastic.
Back to you, James.
Good stuff. I think we've pretty much run out of time. We've only got less than a minute left now, so it just remains for me to thank our presenters today: Marcus Buchner, Director of Product Management with Amdocs, Roy Cylon, VP of Technologies with Atrinet, and thank you, of course, to the audience for all of the fantastic questions. The ones that we didn't get around to answering, we'll follow up via email afterwards. You can download the slides, so please check them out, and any further questions, hopefully you'll know who to reach out to. So thanks again, and I hope this was useful to you. Good day.
Thank you very much, everyone. Bye-bye.
Thanks.